Hello everyone, my name is Giovani Farina and I'm one of the PPCR teaching assistants this year. Today I'm going to show you how to interpret some STATA output from some types of tests. Let's start with a t-test. When we run a t-test, we can see that a lot of numbers show up. And what do those numbers mean? So first, this table, we can see basically the descriptive statistics. We are gonna see first the number of observations or the number of values, the quantity of values that we are evaluating in this test. So we can see first the number of observations for each group and the combined. Combined is the total of the data set. Next we see the mean values for each group, the total mean value, and the difference between the group means. Here we see the standard deviation values for each group and the total, and we can see finally the 95% confidence interval. The values again for each group, the combined values, and the difference between each group. Then after seeing the descriptive statistics, we are gonna see the t-test per se. Here in this test, we are assessing the difference between the mean of the male group minus the mean of the female group. And our null hypothesis here is that this difference is zero. This is the null hypothesis. This is what we are testing with this t-test. So on the left we can see this t-value. The t-value is the final result of the t-test, but this is not very important for our interpretation of this test. So we want to look for the p-value, not the t-value. And here is the p-value. This is the p-value for a two-tailed test. That means the difference is, the result should be different than zero. Could be higher, could be lower than zero, but it's different. This is a two-tailed test. And this number, the PR, is the p-value. Those other two numbers are the p-values for one-tailed tests. So depending on where is the tail, you're gonna look for the different p-values. For the Wilcoxon rank sum or Mann-Whitney test is a little bit different because you may remember that Wilcoxon as a non-parametric test, this test does not compare means, medians, modes. They don't compare, non-parametric tests don't compare any kind of central tendency measure. So what they really assess is the rank sum means. So here we can see the number of observations, the rank sum for each group and the combined, and the expected values. This is usually not very important for the interpretation of the data, the interpretation of the test, but it's really important to understand what it is. So here we can see the z value, which is the result of the Mann-Whitney test, because it is a type of a z-test, and here is our p-value. This is the value we are looking for. For ANOVA, it's kind of similar. First we can see this analysis of variance table. We can see the sum of the squares, the degrees of freedom, and the mean squares for the between groups and the within groups analysis. Here we have the F-test for the between groups analysis, and finally our p-value. If you're doing Bonferroni analysis after ANOVA, you're gonna see the table below showing up after the ANOVA test. And that's the Bonferroni test. Bonferroni evaluates two of the groups at a time. So in this table we are gonna see the row means minus the column means. Let's see, for example, this first one. This number inside the box is our p-value, and the number above the box is the result of the test. Always look for this number inside the box, the second number, because this is the p-value. And this p-value shows that there's no difference between the 46 to 59 group in comparison to the 30 to 45 group. Here, this p-value shows that there is a significant difference between the 60 plus group and the 30 to 45 group. And this one compares the 60 plus with the 46 to 59. Finally, if you are doing Fisher's exact test or chi-square test, first you're gonna see this contingency table, and then you're gonna see your chi-square result and the corresponding p-value and the p-value for the Fisher's exact test. This is pretty simple, pretty straightforward. That's it for today. I hope it helped you to understand a little bit more about the STATA output.